Okay. 2 content objectives left and we're done with this unit. This one is dilation. Okay. So, all right. A dilation that creates an image larger than the pre-image is called an enlargement. You will need to know that. That will be on your worksheet. A dilation that creates an image smaller than the pre-image is called a reduction. You will need to know that too. Certain scale factors, that should ring a bell. Scale factor, you did that last year. Certain scale factors create enlarged images compared to the pre-image. Others create reduced images compared to the original. In this Explorer, you will determine which values of the scale factor create each of these situations. So the first thing we're going to do is we're going to graph this. It says H, so we're going to go over 2, up 2. Then J, over 4, up 2. And K, over 4, up 4. Okay. Now, using a colored pencil, which I will give you here in just a minute, using a colored pencil, graph the image H prime, J prime, K prime at the dilation factor of a half. So I want to explain what we're doing with that half. What we're going to do is we're going to take...
Hunter, stand into the office, please.
And I'm just going to write them down here so I have room. We're going to take all of these coordinates that we just did, and we're going to multiply each one of them by a half. So we're going to take 2 times 0.5, write our new number. 2 times 0.5, write our new number. Okay? So as I'm passing out colored pencils, that is what I would like you guys to be doing. Did you get the same coordinates I did? Multiplying by a half is the same as dividing by 2, just so you know. So anytime you multiply by half, it's the same as dividing by 2. So now we're going to take that, grab that colored pencil, any color that I just handed there, and we're going to graph this guy on our coordinate grid over here. So over 1, up 1, H prime, over 2, up 1, J prime, and over 2, up 2, K prime. Okay. So now you're going to rotate a colored pencil with somebody. I don't care which person. You just need to switch with somebody. So everyone's got a new one. So you guys need to switch with, because three-way switch. Everyone needs a new color. All right. Now what we're going to do is we're going to have these again. We're going to have H double prime, J double prime, and K double prime. Only this time, we're going to multiply our originals by a scale factor of 2. So we're going to take all of these times 2. So our first one would be 4, 4. So multiply all of those by 2.
That's what I'm thinking. Because you said like when storms start coming. Yeah.
Okay, so we should have had 8, 4 here, and then 8, 8. Do you agree? Okay, so now we're going to take that colored pencil, that new one you just got, and we're going to graph that. Over 4, up 4. H double prime. Over 8, up 4. J double prime. And over 8, up 8. K double prime. Okay, so let's just say B is my scale factor. So, if B is my scale factor, if B is greater than 1, do I get an enlargement or do I get a reduction? So this was times 2, this was times 0.5. So if my scale factor, that's what this is down here, if it was greater than 1, did I get a reduction or an enlargement? So did I make the shape bigger or smaller? This one right here, this is greater than 1, right? Do you agree that the scale factor of 2 is greater than 1? So what did this shape give me? Did it give me a bigger shape or a smaller shape? Compared to my original. Here's my original. Did my green one give me a bigger or smaller shape? Bigger, so this is an enlargement. If B is less than 1, that'd be this one right here. Did that give me a bigger or smaller shape? Smaller, so that's a reduction. Okay. I want you to try to answer this one as I pass out the rest of the papers. What type of image does a scale factor of 1 create? So if I took all of my numbers up there times 1, if I took all of these numbers up here times 1, what kind of figure would I get? Would I get an enlargement? Would I get a reduction? Or do I get something else? So think about that. If I took all these numbers up here that I just did times 1, what would that give me? Yes. Yes. All right, what do we think? What would happen if we multiplied it all by 1? It'd be the exact same. What do we call the same in math words? What's that word that means the exact same? Congruent. Very good, Kale. Now, if you wrote that they'd be the exact same, that's fine. But they would. They would be congruent. Nothing would change. All right, let's go ahead and switch gears over to the presentation I just gave you. Oh, I didn't give you. The slide I gave you. Okay, I can dilate an image on a coordinate plane. This is CO4. Guys, we only got one more to go. All right, let's talk about our vocabulary. Dilation. Remember, we talked about this one time before where you go to the eye doctor and they dilate your eyes and what happens to your pupil? They get big. Okay, so dilation is literally changing the size of something. Has it reflect, translate, or rotate? Have I changed the size of anything? No, this is the first one. We're just changing the size. So is dilation going to be congruent if I'm changing the size? No. Can it be similar? Yes, it can be similar because the actual shape itself is staying the same, but the size is changing. Center of dilation is the point in which we do the enlargement or reduction around. And scale factor, that's the one we just talked about. That's what we're actually multiplying it by. And finally, at the bottom here, this is what we just discovered, that a scale factor greater than 1 is going to result in an enlargement, and a scale factor of less than 1 is going to result in a reduction. Okay. Triangle ABC is shown on the coordinate plane at the right. Find the coordinates of the image under the dilation centered around the origin with a scale factor of 2. So first of all, we got to write our pre-image coordinates. So A, what's the coordinate for A? -2, 2. Very good. B. B, not C. Very good. And then finally, you just said C. -2, -2. So those are my pre-image coordinates. Now I'm wanting to get to my image. What did they say my scale factor was that I needed to multiply all these by? 2. So what we're going to do is we're going to multiply all that by 2 to get our image. So -2 times 2 is -4. 2 times 2 is 4. 1 times 2 is 2. 2 times -2 is -4. -2 times 2 is -4. And -2 times 2 is -4. So now I'm going to graph these. -4, 4, A prime. 2, -4, B prime. -4, 4, C prime. Is what? Oh, probably with the wind. Okay, make sure we've got that graphed. Okay, did this create an enlargement or a reduction? Enlargement, because it got bigger. All right, I want you guys to do the same thing down here, just like we just did. Pre-image. Write your, and then your image, and you have a scale factor of 2 again. All right, what's my pre-image coordinate for J? How many did I go over? Say it out loud. 2, and then what? 4. What about K? 1, 1. And what about L? 4, 0? Yeah, you were looking at J, I bet. All right, so now what am I multiplying all these by? What's my scale factor?
2.
So I'm going to multiply them all by 2. So I have 4, 8, 2, 2, 8, 0. Do you guys agree with that? So now we graph J over 4 up 8. Two, 2, 8, 0. Do you notice how it creates the same triangle, but just bigger or smaller, right? Is this an enlargement or a reduction? Enlargement. All right, let's go ahead and go on to the next page. All right, here we have MPK, so we're going to do our pre-image. We're going to write our coordinates just like we've been doing. So M is -4, 2. P is 3, 2. And K is 3, -6. Okay. What's our scale factor this time that we are applying? What'd you say? 0.5. So I'm going to multiply this by 0.5. What did I say multiplying by 0.5 was the same as? Dividing by 2. So let's go ahead and do this. Grab that calculator if you want to. What'd you notice when you had to multiply 3 by 0.5? Did you get a decimal? Is that okay? Don't freak out because it's a decimal. We'll just go halfway through. So if we graph this, -2, 1, here's my M prime. P, then we're going to go over 1, and then halfway through it, and go up 1. So I won't be right on an intersection. That's okay. That's going to happen. Same thing with K, over 1.5, down 3. Is this an enlargement or a reduction? Reduction. Because it's getting smaller. Okay. All right. I'm going to have you guys try. Now, we have A. This is our pre-image. B, C. What is 1/4 as a decimal? What does that equal? 0.25. So you're multiplying these by 0.25. Okay, let's talk about this. What did we get here? We're multiplying all these by 0.25. So this is still going to stay 0, right? But then it's going to be what? 1. This is going to be, oh, I didn't need to write another parenthesis. This is going to be what? 4 times 0.25 is 1, and then negative 1. And these will both be negative 1, right? Okay, so let's graph it. Over 0, up 1. There's A prime. 1, negative 1. B prime. Negative 1, C prime. What happened here? Enlargement or reduction? Almost done, guys. Okay. I just left this in here in case because you will see a rule, maybe on ISAS, but this is the rule. This is what it looks like. It's just saying that B is your scale factor. And then if I take B, if my scale factor, I take my scale factor times my X and I scale factor times my Y. That's all it's saying. That's what the rule might look like. Okay. And very last thing we got to do, we're going to talk through this top one here. All I want to know is we're going to write, is this an enlargement or a reduction? So A, is that going to give me an enlargement or a reduction? What do you think? Times 0.25. Will that give me an enlargement or a reduction? Reduction. B, will that give me an enlargement or a reduction? Is 4 divided by 3 greater than 1 or less than 1? It's greater, so it will give me a enlargement. .6, what will that give me? Is it greater than 1 or less than 1? Is 2.6 greater than 1 or less than 1? Greater, so it'll give me an enlargement. 3/5, is that greater than 1 or less than 1? If we have 3 out of 5 slices of pizza,
Ruby McAllister to the office, please.
it'll give you a reduction. Good job. Now, this bottom part's different. It's not just asking for an enlargement or a reduction. It's asking what transformation's happening. So your options are reflection, translation, rotation, dilation. So you need to decide what you think is happening there and write down which one you think is happening. I'll give you just a couple minutes to do that. All right, what's happening here? What do you think? We're subtracting from the x and adding to the y. Which one is that? Where we add and subtract to it. Huh? No. This is a translation. Translation. When I'm just moving it left, right, up, down, it's a translation. Does that create a congruent or similar figure? When I just move it, does that create a congruent or similar figure? Congruent. What's happening here? I'm multiplying the x by 4 and I'm multiplying the y by 4. Which one is when I multiply x and y? Which one is it? What? Dilation. Does dilation create a similar or congruent figure? Similar. Ah, look at this. X and y, did they switch spots? No. But the y changed to a negative. What happened? What rule is that? If we reflect over the x-axis, the y changes to its opposite. So this is reflection. Does reflection create a similar or congruent figure? Is it the exact same size and the exact same shape? If it's the exact same size and the exact same shape, it's congruent. All right, this one here, we're multiplying by 1.5. What do we do when we multiply by 1.5? If we multiply the x and multiply the y, which one is it? There's only one that we multiply. Dilation. Does that create a similar or congruent figure? Similar. Finally, did x and y switch spots? No, but x changed to its opposite this time. What is it? Reflection. Does reflection create a similar or congruent figure? Congruent. Now hold on. What's the only one you notice that created a similar figure? Dilation. Dilation is the only one out of all the ones we will learn that creates a similar figure because you're adjusting the size.